Well, good morning, everyone. My name is Pedro. This is Leticia, Rafael, Gabriela, and Marcelo. As Professor said, we are students from Brazil. We are part of the BSMP program, and we were sent here by our government to study all around the country in different universities. So we came from different universities across the U.S., and now we're together to be the Solar Batpak group. Our prototype, a little of the backstory of the prototype will be, Leticia will talk with you about it, and that's why I'm gonna hand to her the microphone.
Hello, everybody. Good morning. There was this girl here in IIT. She had tunnel vision, which means that she couldn't see in the sides, and she would bump into people, fall, and get hurt because of that. So there was a group who created a system to help her and people who have the same problem that she has. So they built a prototype in a hat. This is their basic system. They had three ultrasonic sensors, two on the sides, one in the front, that could detect if there's someone or something nearby. They had three vibration motors that could warn the person in case that happens, one Arduino that controlled everything, one touchpad to turn the system on and off, one solar panel to power the system, and one battery to back it up. And this is our prototype. Batpak stands for Battery Powered Awareness of Closeness Kit. We decided to change our system to a backpack because first it was easier to feel the vibration in the shoulders than in the head. In the head might be uncomfortable. The weight would be more evenly distributed in the back, and also the height would be better to sense if someone was nearby. And this is our system. It's quite similar to the other one, but we made a few changes. Like the sensors, we changed from the pink parallax sensors to the LV Maxtoner EZ1 sensors, mostly because the LV sensors, they recognize better soft objects like clothes, therefore they're better to recognize people. We also changed a little bit the code. The code of the previous group had a really big bug in which they tried to access a space in an array that did not exist. As you can see, they created an array with 20 positions. The index go from 0 to 19, and then they tried to access the position with index 20, and that could just break the whole system, so we had to fix that. One other thing that we did, we changed the range and the vibrating levels. The previous group, they had a maximal detectable distance of 70 centimeters, which is like 2.2 feet. And we thought that was not enough to sense if someone was coming towards you. So we changed that to 2 meters, which is like 6 feet. And they also had like 7 different vibrating levels. And we thought that the difference between 2 vibrating levels was not very noticeable, so we changed that to 4 vibrating levels. And we have a demo video to show you the 4 vibrating levels. We use an LED instead of the vibrating motor, so you can see the output. So you can see that as he's approaching the backpack, the LED starts flashing more frequently. So that's our 4 vibrating levels, and now I'm gonna pass it to Peter. He's gonna talk about some other changes that we made in the previous prototype.
So these were some of the changes we did from the previous prototype, but the big problem from the previous prototype, besides being the head, the vibration motors being on your head, so maybe you could have a headache, was they had a huge problem with the delay. And delay in this kind of project is very serious because it can be the difference between colliding with someone and avoiding someone. So we're gonna show you a video from the previous prototype working. And as you can see, there's a big gap between put the hand on and then the user feeling it. So we thought that was not good enough, and we put a lot of effort trying to figure out why this was happening, if it was the sensor or the code. And in the end, we discovered that the problem was the noise filtering that you were using. We were using an average function. So we were using 20 numbers, so you wouldn't have noise being the problem. But the problem was to make the average go down. That took a long time and then they send the information to the motors to vibrate. So we had a difficult choice to make. We were gonna use the noise filtering and have a delay, or not using any filtering and have no delay. So since we said delay is a huge problem, since we are working with someone that doesn't have a perfect vision, it can be the difference between colliding, hurting himself or not. So we decided to have no noise filtering and have some noise time to time, but have a much better response. So we have no delay right now, as you can see on this video. This is our final code. As you can see, the hand goes on, the LED goes on, almost in the same time. And the sensors are very good. They can even identify dinosaurs behind the user. But since we're talking about all these electrical components, we need to talk how we get the energy for all this. The previous prototype, if you saw the circuit, they have a flexible solar panel, but they had no idea how much energy they were producing or consuming. So after some tests, we discovered that one flexible solar panel was not enough. They were not providing enough energy to supply the system. And because of that, we figured out two possible solutions. The first one used two flexible solar panels to increase the output. The other one was use a different technology, a hard solar panel that will produce more energy than the previous one. Because we decided to stay with our final prototype with the two solar panels, both of them work, but the two solar panels has a better response to shade. The other one has a much decrease on its current when you have shade on the solar panel. Since we're producing energy, we have to store it. That's why we're using a 1200 milliamp hour battery. For people that doesn't have idea how much that is, it's like an old Android cell phone battery. And we're producing, storaging, but we have to use the energy in an efficiency way. So the previous prototype have a very huge problem with their turning off system. Because when they turn off the system using the touchpad, the only thing that changed was the vibration motor was not working anymore. But all the other parts of the system will work on some energy. So our first idea to change that was using a button to put the Arduino to sleep mode. When you do that to Arduino, it starts consuming much less energy than while they are, instead of being on the whole time. But even though it was just a small current, we were still wasting energy. So we tried to make even better. And in the end, we changed to a switch. And then right now, when you turn off our prototype, you cut all the energy going to the system, and all the energy you're producing is just going to the battery. So we're not wasting energy, we're just storing it for later. And with all these changes, with the better production and consumption, we can say, like, pretty secure that our system can work a full day without need to go to any charging or without the need to go to the grid. Even though we have some system that if you want to charge your backpack during the night, you can plug in any USB ports and leave it in charging for the night and use in the morning. So without further ado, these two are our prototypes. This one is the first version of our prototype. You had this hard solar panel, and here you got the two flexible solar panel in a better way displays than just this. So if you guys have any questions later, if you guys want to try our prototypes, they are both working. We'll be on the corner in the end of all presentation. Feel free to come and ask any question you want later and test our prototype. And thank you very much for your attention. And this is our group.